Guys, this is Suck, and today we are looking at what happens at plate boundaries. So Earth's outer layer, the crust, is divided into a set of large moving plates, and the lines where these plates meet are called plate boundaries. Now there are four main different plate boundaries, and we've got to learn what happens at each. Now the first one is destructive margins, and a destructive margin is when oceanic crust moves towards another plate. Now because the oceanic crust is heavier, it's forced downwards. Now as it is forced downwards, the pressure increases, which can cause violent earthquakes. At the same time, the heat produced by friction turns the descending crust into magma. So this hot magma tries to rise to the top, and when it succeeds there is a major volcanic eruption, and that's why it's really called destructive, because of this major volcanic eruption. The next one is collision margins. Now collision margins occur when the two plates are both continental crust, and because continental crust cannot sink or be destroyed, the land between pushed upwards to form high-fold mountains, and this is where you can find, if you go to the Himalayas, this is how that is formed. Now although the pressure can create earthquakes, there are no volcanic eruptions. So basically both the continental crust, they cannot sink, and therefore rocks form in a bed and they're pushed up and they're forced up. Now the next one is constructive margins. Now a constructive margin is where the plates move apart, and as the gap opens between the two plates, the lava can easily escape, either in the form of a gentle eruption or a lava flow. The lava creates new oceanic crust and forms a mid-ocean ridge. Now while the earthquakes and eruptions are not gentle, they are gentle compared to other plates. Now an example where there are constructive margins is, for example, Iceland, and that's why there are a few earthquakes and volcanoes in Iceland. Now the final one is conservative margins, and this is where two plates try and slide past each other. However, one of the two plates stick, as they often do in San Andreas Fault, which is in California. Now the pressure then builds up, and when it is released, a severe earthquake occurs. Now as the crust isn't destroyed or created, there isn't any volcanic eruption. So thank you very much for watching this video. Can you please visit my other channel, which is GCSE Languages, and subscribe to this channel. Thank you, and see you soon. Bye.
Okay, we're going to look at the final plate boundary, which is a conservative plate boundary. These are the most straightforward to understand. And the main example of this, so your AO1, being able to identify an area, will be San Andreas in California. So the North American and the Pacific plate are involved in this process. So let's have a look at how it works. The plates move sideways past each other. Okay, nothing is created and nothing is destroyed. That's why they call it conservative. Conservative means to stay the same. But they can be very destructive, these. So, although few volcanic eruptions occur, earthquakes are frequent and can be very, very strong. Because as they're moving past each other, occasionally they can snag. Okay? What that means is they can hit together. And where that does, that allows a lot of pressure to build up. And when they snap, this creates violent earthquakes on the surface. Okay, so in Los Angeles there has been numerous occasions over the years where there's been big earthquakes, and some scientists believe that there is going to be one inevitably in the next 30 years because the build-up on the San Andreas Fault is just waiting to be released. So you've got two plates, one's moving one way, one moves the other. Nothing is created, no volcanoes are involved in this, but it can snag. So imagine it like this. You've got two of these plates and they knock onto each other a little bit like this. Where that part has happened, that's called the epicenter. So that's where the earthquake's going to start, because here they are snagged together. When they are released, that releases the pressure, and that creates the earthquake. So the key terms from here would be the epicenter, where they snag. The key signs there is that they're both moving in opposite directions. And the key location would be San Andreas, California, is your main example of where that's happened in the past and where unfortunately it will happen in the future. So that is what a conservative plate boundary is. I hope that's clear. Let's just go through it again. So you've got one plate moving one direction, you've got another plate moving in the other direction. Now and again they will snag. Where they snag together, it builds up pressure. When that pressure is released, that is the epicenter. That is where the rocks were hitting each other and now they've released. And this creates an earthquake, a very violent earthquake and powerful. Okay, I hope that's clear. Thank you for your time. Hello, we're going to discuss what a constructive plate boundary is today. And we're going to use diagrams, illustrations, so you're all very clear on exactly what the science is behind a constructive plate boundary. Essentially, it should be looked at like this. This is a diagram that could come up in your GCSE exam or any exam, and this gives a full explanation of what goes on. Have a look at the arrows here. Constructive means to create, to build, like Lego. Something new is being created. So, if you have a look at the diagrams, it simply means that the plates are moving apart. And what is happening is that as the plates move apart, magma, which is lava underground, is rising to the surface. And when it rises to the surface, it forms large ridges and volcanoes. Now, because these happen, it's called a mid-Atlantic ridge. So new magma is pushing up and the new volcanoes and new ridges under the sea are being created. So the plates move apart, mantle magma moves up, and a new ridge, volcano, is created. That's the basic science behind it. You may be asked to actually explain this or label a diagram. If so, this is the core information that you need to know. But essentially, constructive, again, just to over-communicate the point, means to create. So that's the AO2. That's describing what happens. For AO1 and AO3, which are identification and explanation, you need an example. And this is your main example. This is Iceland, which is on a plate boundary that is moving apart. So the Eurasian plate, which is where Europe is, and the North American plate, which is United States, are moving apart. And all this happens right slap bang in the middle here is Iceland. So as they move apart, new volcanoes and new matter, new land, new ridges are created. And every year they move further and further apart. So this is why this area of Iceland has lots of volcanoes. Also, if you remember a few years ago, a volcano erupted because of this plate and lots of ash came out and it disrupted flights around Europe for a number of weeks. So this would be your AO1. That's your example, Iceland. It's on the mid-Atlantic ridge, which is the constructive plate boundary. They're moving apart. As they move apart, magma rises to the surface and creates a ridge or volcano. New matter is created. Essentially, that is everything you need to know for a constructive plate boundary. Sorry, I'm spitting my words there. So, if this comes up in an exam, which it will, you've got to be able to explain. I just keep it simple like this. Those will be the notes that I'd scribble on the side of my exam paper, just so I'm clear, just so it's crystal clear what you're doing. Okay? Thank you. Hello there. We're going to discuss what a destructive plate boundary is. And we're going to use our three skills. Identify, AO1, describe, AO2, explain, AO3. Destructive then. To destroy. Something has been broken, something has been destroyed. We all understand that word means. So that should be at the forefront of your mind when you are thinking about these plate boundaries. So, what happens in this process then? We've got two plate boundaries. And instead of creating something new like a constructive one does, we've got a situation here. Now the ocean crust, or continental crust, is thin. And it's lighter than the continental crust. So this is heavy, this is thicker. Alright? Think about it like a slice of bread and a rock. Okay? There's only going to be one winner, this one. So as they're pushed against each other, the continental crust, the oceanic crust, is pushed underneath the continental crust. So it's pushed underneath there. It's going to go under. Now when that happens, it creates something called a subduction zone. That's here, that's that dip there. Alright? So it's buckled, it's gone underneath. As this happens then, creates a mountain range. Okay? And as this crust starts to go underneath, it starts to melt and form new magma. This is because of the friction between the moving plates. Okay? So as it goes underneath, it actually pushes up and helps create the mountain range. Alright? Now this sometimes can cause a lot of pressure and it can create earthquakes and volcanic eruptions. So you might be thinking, oh wait a minute, how can it be destructive if it creates something? Well, it's because what it creates is more destructive. So essentially, one goes underneath. So we've got the land, we've got the ocean, it goes underneath, and as it pushes that up, it creates a mountain range, and this is called the subduction zone. Okay, so that can create earthquakes, which is destructive. So, let's go through it again. So we've got our ocean crust, which is thin, and we've got our land crust, our continental crust, which is thick. This goes underneath, creates a subduction zone, which is like this triangle effect here, a big trench, and as it pushes underneath, it creates a mountain range, okay, which can have volcanoes in. Because it's so temperamental and this is constantly moving down, if it does snag, it creates an earthquake. Let's go through it again. Thin, thick, goes under, creates mountains, subduction zone, can create earthquakes. Let's go through it again. Thin, and then we've got a thicker one there. We'll do that in red. We've got a subduction zone, which is a big trench, and as it pushes up, it creates a mountain range. Hope that's clear. Okay, so the main example of this would be the Andes in South America. Okay, as the South American plate is land, and the Nazca plate coming from the Pacific Sea is thin, that goes under, creates a subduction zone, which is your trench, creates mountains, but can also create earthquakes. Okay,